So starting with the magnetism chapter, not electromagnetism, only magnetism. So in this chapter, we will only talk about the properties of magnets and magnet related properties or the concepts. So basically, when we move charge from one place to another, just like in the last chapter, we talk about the charges, there are electric field around the charges, positive, negative. We have two different charges and they have their own electric field depending upon the magnitude of the charge. So what happens in the magnetism? When we talk about the moving charges, so when charges starts to move, so moving charges produce magnetic field around.
Sir, moving charges as in current?
Yes, but for right now, we are only talking about electric field, right? So we are not going to discuss very detailed about electric current. So
Okay.
still, if we talk about the last concept, the conduction of the charges. So when charge move from one point to another, so definitely their field will also be disturbed when they move from one point to another point, right? But when they are still just like this, so we will make field like this. But when they move, starts to move, so definitely their field lines will also disturb because now they are not in any fixed state. So this is the basic idea. When they starts to move, so they also produce magnetic field, right? They own electric field already, but when they starts to move, so they produce magnetic field around. And we all know that because of free electrons, only electrons are free to move. So basically free electrons are again responsible to produce this magnetic field. So second important point is electrons are responsible to produce magnetism. So electrons are responsible to produce electric field, and when those charges are moving, so definitely electrons are also responsible for the magnetic field around the magnets also, or around the properties or the matters that we are going to discuss today. So this is the basic idea of the magnetic field, right? And basically if we talk about like structure, we know that in magnets we have north pole and south pole, right?
Yes. Yeah.
So we all know about the magnets because these are very common thing, and we perform many experiments with magnets in our school, in our home also. So we know there are magnetic poles like north pole and south pole. Okay, so basically if we talk about the background, that what is the property behind or in the internal structure of the magnet, that not all materials are magnet, few of them are magnet. So what is the difference between them, right? So let's suppose if you consider two different structures. Basically the concept of the charges and the magnetism is very much like detailed one and very vast, but right now in our syllabus we are only talking about some basic properties. But if somebody continue with the higher studies with sciences, so then you will observe that there are many detailed concepts related to this magnetism and this electrical field concepts. So let's suppose if we have two different materials, and in that materials if we mark some divisions, and same division in the second material. So basically in the first two lines you observe that we are talking about the motion of the charges, like motion of electrons, because electrons are free to move. So let's suppose if you get the orientation of uh, all the tiny domains, like we divide this whole structure or this whole matter into small partitions. So let's suppose if we identify the direction, because the motion of electron will also cause the magnetism or the magnetic field around. So if we identify the direction of magnetic field, so if you are using a magnet, so in magnet the field directions are all aligned in same direction like this. You will get the orientation of all the field lines or the orientation of their directions all in a single way like this. There will be no other direction or any different orientation for any single charge or single field line. So when you got all the tiny domains aligned in a single direction, so that metal acts like a magnet. Okay, just like the first example. But if you compare with another material, so let's suppose in the other material we have different domains with different orientations like this. So in all domains you are getting different directions. So basically this is the reason or the concept of domains. In the first material make partitions, so those partitions are actually domains. So all tiny domains align in one direction. So metal act as a magnet. Take a metal, and in the metal this is like the behind scenes of the particles, that what is going on behind the magnet. So all the tiny domains, when all tiny domains align in a single direction, so that metal act as a magnet. And in second diagram you observe their orientations are not same, so this misaligned magnetic domains are not for a magnet. So in second we are getting misaligned magnetic domains. So it means this material is not a magnet. So this is a logical reason basically. Let's suppose if someone asks you about the magnets, that why not all metals are the magnet. So this is the answer, simple answer at this level, that there is the orientation of the magnetic domains, and if all domains are in a straight line or in a single direction, so definitely that material or that metal should be act like a magnet, otherwise not. Now continue with some basic knowledge of the magnets also. We know that there are two poles of a magnet. You all know about them, north pole and the south pole, very basic. In static electricity we talk about the charges. In magnetism we are talking about the poles. So we have north pole and south pole. Again, the same properties just like we discussed in the concept of static electricity. Same poles repel each other, unlike poles attract each other. These are also very basic things. but still these all concepts are included in your exams. So same poles repel each other, unlike each other. And third one, force between them also depends upon strength of both magnets. So if the strength of magnetic or the magnetic poles is very high, so definitely they will apply greater force. And if the magnets are like very small and very weak, so definitely they will apply very less force on each other. So this is also a very basic knowledge. Clear? Any confusion till now?
No, sir.
Because only
No.
the alignment of the domain is a new concept, and all other concepts are like the old one. You all know about these things. And after this, we have idea of magnetic materials and non-magnetic materials. If we consider magnetic material, because in MCQs you will get questions like this, and in theory question these terms will also help you to identify the question that what they are asking actually in the question. So if we talk about magnetic materials, so magnetic materials are like iron, nickel, cobalt. So these materials can be turned into a magnet. But some are like non-magnetic materials like brass, gold, copper, aluminium. So those materials are not magnetic materials. We cannot make magnet from those materials.
Sir, how would we magnetize a non-magnetic material?
Basically, to magnetize them, there are two methods. Very basic method. If you place that magnetic material with magnet, or if you rub on the magnet, so after some time it will get some magnetic property for very short time. That is temporary magnet. And the other method is electromagnetism. We will also discuss in detail because these all topics are included in our syllabus one by one. Like if you wound a wire on the magnetic material and you pass current through it, so electromagnetically, because we already discussed that moving charges produce magnetic field. So when charge move through that wire, it produces magnetic field, and that magnetic material absorbs that magnetic field, and it will become electrically magnet, but that is
So
temporary.
in generators, would they use this type of magnet?
Same concept. We are using electromagnetic in our daily life because electromagnetic, like when we are going to use magnets, so we magnetize them, and when we don't require them, so we just turn off the current and it will be lose its magnetism. So in this way it is very helpful, because if you are using permanent magnets, so that will remain permanently magnet always. But in our process nowadays, we know, like that crane which you observe in the films or in the movies also, that they lift some thrash from the magnetic or the old thrashed car, all are metal. So they just picked up the metal very easily because it is electrically magnetized. And when that crane wants to drop that metal thrash, so they just turn on the device, turn off the electric currents, and it will become non-magnetized. So these all things are based on electromagnetism. That's why electromagnetism is very important after this charges and magnetism section. So second we have non-magnetic material, because these names are very important when they ask you to differentiate or to pick from the MCQs. So then we got confused in them. So non-magnetic materials, definitely first of all non-metals, right? Like plastic, glass, rubber, all these things are non-magnetic. So all non-metals are non-magnetic. Plus, if we talk about some metals, so brass, gold, and definitely you will also try this or you already tried this experiment when you place any aluminium material with the magnet, so it will not attract towards the magnet. Like if we take coins, so coins are not going to be attracted by the magnet because mostly coins are made up from brass or copper, so they are not going to attract towards the magnet because they are non magnetic material. Again, the same problem, their alignments are not in a straight domain, so that's why they are not magnetic material. Aluminium windows, if you try to stick your magnet on aluminium windows, they will never stick on it because aluminium is also non-magnetic material, right? Okay, after this there is one more topic from which in your exam you will get many concepts, many questions, and that concept is related to hard magnetic material and soft magnetic material. Because at the end we are only talking about the magnetic properties, so definitely we have to discuss about them. If we talk about hard magnetic material, and if we talk about soft magnetic material, so what is the difference between these two terms? So there is a clear difference between these two terms. The first difference is that when we are talking about hard magnetic material, I will also give you example for that. So the first thing to differentiate is that these materials are difficult to magnetize. Just like you asked how to magnetize them, so if you try to magnetize hard magnetic material, so they are difficult to magnetize and also demagnetize.
Sir, to demagnetize, we would just hit it with a hammer or heat it up, right?
Yes, so these are the process that you already studied somewhere related to the magnetism. And if we talk about soft material, just like we are talking about the example of the machinery, so in machinery we mostly use soft magnetic material because we had that magnetic property for very short time or temporarily we required that one. So that's why soft materials are magnetized and demagnetized also. Next, they retain their magnetism, and for soft magnetic material they lose their magnetism after some time. That's why they called temporary magnets. After this, we use these type of material to make permanent magnets. Used to make permanent magnet. Next, definitely we use soft materials to use them as temporary magnet, or we can also call electromagnet. And the final important thing, the example. So mostly in your syllabus, they will ask you between two materials. The first one is the steel. So always remember, if they ask about the steel, so steel, we will use this material to make permanent magnet. And if we talk about the iron, so iron will be used to make temporary magnets, right? So in your exam, in your syllabus, these two names are very important because they will not ask about all the different types of magnetic or non-magnetic material. So they will only ask about steel or iron. Okay. So this is the basic idea of the magnetism. And
Okay, sir.
definitely, okay. Any confusion, any question till now? I hope this
No,
concept
sir.
is not very much difficult because
Sir,
mostly
it's not
we
difficult.
all know about these things. Only few terms we have to memorize from this chapter, because in your exam they also ask about uh, what we say, these terms, because they ask about the reference of these terms, so that's why it is important for you also. And second important thing, just like the electric field, there is a concept of magnetic field, right? So in the concept of the magnetic field, if we want to define the magnetic field, so anybody wants to define how the definition of the magnetic field will be? If you take the reference from the previous electric field concept, okay, so if we start with the concept of magnetic field, so in electric field we discussed that there is a region around the charge where another charge experiences the electric field, or the electrical force or the electrostatic force by the first charge. Same, we are living on the surface of the earth, so earth also applies the force of attraction because of gravity, right? So that is called the gravitational field strength or the gravitational field. So this is the concept. Same happens with the magnetic field. So in next we will start with magnetic field.